afternoon, everyone. Today I'm going to introduce you a new method, genome-wide association study, and how it reveals the genetic risk underlying Parkinson's disease. As we all know, diseases in neurology are always difficult to diagnose and treat. And there are many methods are developed to solve this problem. One of them is genome-wide association study. Genome-wide association study is an examination to find out the association between the genetic variants and the trait, among which the genetic variance is always the SNPs and the trait are always major diseases. In another word, we are going to find out the association between the SNPs and the major diseases. SNPs, namely single nucleotide polymorphism, is the DNA sequence variation. As it shows in this video, it may be CG in a person, and it will vary into a TA in another person. So it's a difference in the single nucleotide. And in a specific location of gene, if the variation of the SNPs is stable, it means the variation of the SNPs is associated with the disease. And the recent research indicates that there is a high mobility of the Parkinson's disease. So let's take PD as an example to investigate into GWAS. And first of all, we should set up two groups. The case group includes patients with PD, and the control group include healthy persons. Secondly, we should do some genotype to all the individuals to get to know all the SNPs. The genotype is the genetic makeup or the allele makeup of an individual. As it is shown in this figure, the capital B is the gene in this chromosome, while the small b is the allele gene on the other chromosome. So a capital B and a small b is the genotype for this individual. And thirdly, to investigate all SNPs to see if the allele frequency is significantly altered between the case and the control group, so that we could get an odds ratio. The odds ratio equals the P case divided by the P control. The P case is the proportions of individuals in the case group having a specific allele, and the P control is the proportions of individuals in the control group having the same allele. If the OR is bigger than 1, it means the allele frequency in the case group is much bigger than in the control group, which reveals that the allele gene is associated with the disease. And finally, we could get a Manhattan plot to see it directly. As it's shown in this figure, this is the X value, which is the P value, and this is the exon, which is the chromosome. As it's shown in this figure, the dots in red reveals that all some genes on chromosome 4 and chromosome 17 has a relationship between with the Parkinson's disease. And we should go into a further study. We found out that the gene of SNCA, MAPT, PARK16, and LRRK2 also has a relationship with PD. If all these genes were detected expressed in the patient, so that it may show us that there is a high risk that he or she may get a PD. And further investigations could be done to find out how the genes function in the disease, so that we could get another new treatment. In conclusion, by finding out the association of SNPs and diseases, GWAS could help to improve diagnostics, designing new drugs, and explaining the pathophysiologies. It could be used not only in neurology but also in some other subjects. It's a very useful method. This is all for my speech, and there are some minutes left. If you have any question, you could ask me.